In this video, we'll do one practice from each of the main things that we talked about in this unit. First one is the most recent. If we want to find an antiderivative, we're going to have to do two antiderivatives here because they give us f double prime and we want f. Now notice they do give us 2 points for f. So we'll start out to find f prime of t. Don't worry about the 2. Antiderivative of e to the t is e to the t, and then just bring the 2 back out front. Antiderivative of sine is a negative cos times the 3 will give us negative 3 cos t, and then we'll have a plus c on the end. Well, we don't have any points from f prime, so we'll keep going to f. We'll have 2 e to the t again. Antiderivative of a cos is a sine, because think of that as the negative 3. Don't worry about it for now. Antiderivative of just a regular cos. So we'll have negative 3 sine t plus ct plus d. Now, it's probably going to be easiest to plug in the 0, 0 first. So we'll put 0 in for y. We'll have 2 times e to the 0 minus 3 sine of 0 plus c times 0 plus d. Well, we'll get 0 equals e to the 0 is 1. 1 times 2 is 2. Sine of 0, 0. Negative 3 times 0, 0. C times 0 is 0. And then we'll have the plus d. So negative 2 will be our value for d. So we'll go ahead and we'll put that in. So we know f of t is equal to 2 e to the t minus 3 sine t plus ct plus 2. Our other point was pi comma 0. So we'll put 0 in for y and pi in for t. So 2e to the pi is just a constant, so that stays as it is. Sine of pi is 0, so that wipes out the negative 3 sine pi. What we'll do is we'll subtract. Oops, you know what? I wrote this in as a plus 2. This should be a minus 2 on the end. Sorry about that. We'll subtract the 2e pi over, so we'll have minus 2e to the pi. We'll add the 2 over, so we'll have plus 2, and that'll be equal to pi times c. To get c by itself, we'll divide the pi over, so we'll have negative 2e pi plus 2 all over pi. And it's kind of nasty looking, but it's just a constant. That's what our c will equal. That's what's going to multiply our t. So we'll put it all together now, and f of t will equal 2e to the t minus 3 sine t. Our c now, we'll put it in parentheses. We've got minus 2 e to the pi plus 2 over pi times t, and then our minus 2 at the end. So that was one main type of problem we see in this unit. Another was what we started with our L'Hopital's rule. Remember, to use L'Hopital's rule, you need 0 over 0 or some type of infinity over infinity. Well, in the numerator, we got natural log of x, which looks something like that. So as x gets huge, y is going to get huge. Square root of x kind of looks like that, so same thing. As x gets huge, y is going to get huge. We'll take the derivative of each individually, and we'll have the limit as x approaches infinity of 1 over x. Remember, we'll think of this as x to the 1/2. So in the denominator, we'll have 1/2 x to the negative 1/2. And we're going to neaten this up first before we go further. This is the same as saying 1 over x over 1 over 2 square root of x. Well, if we think of this with keep, change, flip, This is really 1 over x times 2 squared of x over 1. So this is 2 squared of x over x. Remember, this is an x to the first on the bottom, and it's an x to the 1/2 on the top. So really, an x to the 1/2 or a square root of x cancels out, and you're left with 2 over square root of x. Another way of thinking of it is x on the bottom is like saying square root of x times square root of x, so one of the square roots of x cancels out. So that is really what we are taking the limit of now as x approaches infinity. So here, there's nothing to plug in the top. Oops, and this shouldn't be an equals. This should just be of. As our denominator gets huge and the numerator stays the same, we will get closer and closer to 0. We'll get a fraction that keeps getting smaller and smaller. So that means our overall limit of natural log of x, square root of x, over square root of x is just 0. And the third main type we saw was Newton's approximation, or Newton's method. Some cases they might give you a starting value, like here they gave us x1. Other times you will have to plug it into your calculator and eyeball what it looks like the root is. So we need our original and f1 in our calculator. And in f2, we'll put our derivative, 5x to the 4th minus 1. So we'll go to a graphs page, and we'll put those in. Make sure after you raise it to the 5th, you hit the right arrow to bring it back down out of the exponent. Now, if we did have to eyeball it ourselves, remember sometimes it's best to eyeball it after you've only put an f1 before you get that derivative graph on there, making it a little bit messier. Hit tab, remember to get f2 up. We'll have 5x raised to the 4th. Again, hit the right arrow to make it come out of the exponent, and you got your negative minus 1. To add a calculator page. Now again, remember you want those to be in F1 and F2 just to keep it consistent. So if you had a document already open, you wanted to open a new document from your home page. We'll do Control Doc to add a calculator page. Put in whatever your initial guess is, so 1, and hit enter. And then we did answer minus. We did a fraction where we had F1 of our answer over F2 of our answer. So really it's our original at our chosen x value. Oops, and I put an F1. That needs to be F2. Over our derivative of that x value. And remember, you want to hit Control, or actually you can hit Enter for this one, and it'll give us our new part, which is 5/4. That also can be 1.25. So x2 will equal 1.25, or you could write it as 5/4. Now notice, they're not telling us to stop at a certain decimal point matchup. They just want us to do the third approximation. That's another way of saying, just find what x3 is. So we just have to do this once more. Now remember, the next time you do it, always hit Control Enter so it puts your new answer in there each time. So we've got our answer. They wanted it to 4 decimal places, so we're going to have 1.125. 178, and that'll round up to 5. So remember, the two different ways they could ask or tell you when to stop, or either tell you a certain number of approximations. So in this case, they did that, and we stopped at x3. Or they could say until it matches to like 8 decimal places. So you'll just keep rounding your answer to the 8th decimal place, and you'll keep going until your x that you get matches the previous x. That's it for today's lesson. We'll see you next class period.